Alright, so if we have the plane flying the southwesterly direction, that would be 225. Okay. So we want to write the vector that represents the magnitude and direction of the jet. So I'm going to write vector for jet. And then for me to write the unit vector, so just keeping in mind the direction, then I need to do cos theta and sine theta, right? So I'm going to say cos 225 and sine 225. So this represents which direction the jet is flying. It doesn't tell you how long the vector is, it just tells you what direction it goes. How do I add in the part that includes the length of the vector? Yeah, the 550. Alright, so in front I'm going to multiply by the magnitude. And if I distribute that, then I'll have a vector that truly does have not only the direction but also the correct length. So the vector for the jet is 550 cos 225I plus 550 sine 225j. Yeah. Alright. Next we want to look at the wind. So it says we have a jet stream, and I always thought a jet stream was like from a jet, like the jet's flying and then there's like wind behind it. But a jet stream is actually, here's a picture of it, a jet stream is westerly winds. So like here's a picture of a jet stream, which is kind of weird, but they're just currents that are found in the atmosphere. So when they're talking about a jet stream in this problem, they're literally just talking about wind that happens to flow. Interesting. And it goes from west to east. So if we look at this one, it says the jet stream is 80 miles per hour and it's from the west. So if we draw a picture of that, if the jet stream is coming from the west, then which way is it going? To the east. So if the jet stream is going to the east, what degree measure would that be? What degree measure is right here? 0. So this is 0 degrees in standard position. Okay, so if we have the vector, I'm going to put W for wind, so I don't use J for jet stream, because J for jet and J for jet stream is confusing. Okay, so the vector for the wind should be cos of 0 degrees plus sine of 0 degrees. And don't forget your I's and J's in there. So we have our horizontal component and our vertical component. And then what should I put in the front to make sure I have the length there? 80, because it's 80 miles per hour. So now I'll go ahead and distribute that. Oh, I guess I don't need that. Okay. Are we comfortable so far? Okay, so here's what we want to picture. We have a jet that is flying completely southwest. And we have air, we have wind that's pushing at it going towards the east. So what's going to happen to that plane if it has air pushing on it the entire time? Is it going to go exactly where it was trying to go? No, it's going to be pushed over a little bit, right? So what we're going to do is we're going to draw, this is the vector for the jet, and we're going to add the wind to it. So there's the vector for the wind. And if I add the vector for the jet and the vector for the wind together, then my resultant for vector addition is going to be where the jet actually flies because the wind has been acting on it. Does that make sense? So this part right here, the resultant, would be the vector of the jet plus the vector of the wind. And the notation that we use for that is vector of the jet plus wind. We put them together. Okay. And we have added vectors together, right? We know how to do that. So if this is the vector for my wind, and this is the vector for my jet, then how do I add those together to find the resultant? Yeah, you put the i's together. We're going to add the i's because those are like terms. We're going to add the j's because those are like terms. Does that make sense? Okay, so I'm going to say the vector of the jet plus the wind together, and I'm going to put the whole mess that goes in front of the i's. That's all the coast stuff. And then I'm also going to have the whole mess that goes in front of the j's, and that would be the sign stuff. Okay, so for coast, I've got 550 coast 225 plus 80 coast 0. That's all the stuff there. And then for my vertical component, I have the 550 sine 225 plus 80 sine 0. And this process might feel a little bit weird, but it works out the same every time. You're going to be able to think of it this way every time. Okay? Alright, I don't know about you guys, but I don't feel like writing that again. So what I'm going to do is I'm going to type this into my calculator and store it as x, and I'm going to use x because that's the horizontal component. And I'm going to type this one in my calculator and store it as y because that's my vertical component, and that way I'll remember which is which. So make sure you're in degrees when you type this in. So I stored it as x and y, or you could store it as I and j if you wanted to. That would also make sense. It's up to you. Yeah, I'm thinking of the x as like the horizontal piece of it, and then the y is the vertical piece of it. Well, these are two different numbers, so you're going to have to store them as two different letters in your calculator so you don't mix them up. Okay. So I'm going to go ahead and label this now. Like this, if I were to think about this, because we know we're talking about speed, but it's also a length. So what I have done is I've built a triangle, and the length of this side of my triangle is 550, and the length of this side of my triangle is 80, and I do not know the length of the third side of my triangle. I'm not sure what it is. Okay? So for number 6, I'm going to go ahead and draw. This is the direction the plane is actually flying, right? That's the vector of the jet plus the wind together as they're being acted upon. So how could I find the magnitude of this? So this is the vector that we have. How could I find the magnitude of that? Do you guys remember how to find the magnitude of a vector? Yeah. So the magnitude of this vector, what do I do? Yeah, x squared plus y squared. Okay, so let's go ahead and type it in and see what we get. So how fast is the plane actually flying? Yeah. And does that make sense if it's flying into some wind, that the wind is pushing it back, the wind would slow it down a little bit? Okay. So we're going to say when we typed this in, we got 496.7 miles per hour. And we're going to leave it right there for today so we don't overwhelm ourselves. Sound good? How are your brains feeling? Are we okay?
What did you have as an x value?
My x value I used as my horizontal component. So, oh, what did it ask? Actually, it was 308. Negative 308.